the total resistance RT in figure 1. All right, we're going to do the same in figure 2, and then figure 3, and finally figure 4 respectively. This is figure 1, this is figure 1, this is figure 2, and then this is a figure 3, and finally this is the figure 4. In each case, we are expected to calculate the total resistance in each case, that is RT. All right, so let's quickly delve into that. But before I continue, remember to subscribe, okay? Subscribe, all right? Share with your friends, with your students, with your networks. Give us some thumbs up, all right? Remember to put the bell button on for constant notifications each time content like this are uploaded. Better still, drop the topic that you want me to treat next time in the comment box, all right? Drop it. Whatever it is, drop it. I am going to handle it for your learning pleasure. All right, so now our next slide, we are going to look at how this can be done. So the first figure is two resistors offering resistances connected in series. We are going to look at that quickly. All right, two resistors, all right, connected in series first of all, and then another two connected in parallel respectively. Let's see how that arrangement works out here. We're going to be very careful in order to get exactly what the figure represents so that we don't mix things up, right? Okay, so let's see. We are trying to get the diagrams properly drawn. All right, this is okay, and we have this, even though it's going to take out a bit time, but it's better we draw it for learning's sake and pleasure. All right, so this is exactly, I can still cover this. This is very interesting. We can still cover it here, all right, and then extend this to a point that makes meaning. We can extend it to this point. All right, so this is our figure 1. Let's do something meaningful here. Take our eraser, remove this, all right, this one's, all right, so that is it. Remove this, and then we redraw once again to get a perfect illustration of what we are trying to explain. Okay, we remove all this. So what we need to do is go back to our ball pen again, pick it, and then go back, draw it neatly. At this point, we'll put another resistor in parallel. All right, yeah, good. So we complete the circuit in this way. Come down to this point, draw another resistor. Okay, by the time we draw this resistor, it's going to be in parallel. Yes, so we have this, and then we can now quickly close as follows. So we're going to find the total resistance in this network. All right, don't mind the diagram, it's just an illustration that will help us understand how this can be solved. So we are going to look at, we're going to calculate for total resistance, right? The first resistance is R1. This is R1. Okay, this is R1. All right, this is R2. Okay, then this is a R3, so to say. R3, good, and this is R4. All right, this is R4. All right, so briefly, let's just look at their various values, because that will help us to know exactly what we're going to calculate. So the value here is 3, 2, 5, and 10. 3, 2, 5, and 10. Let's go back to where we're going to solve this. This is 3 ohms, all right? Yes, that is why it's important for us to know how to draw it. 3, 2, 5, and 10. So we're going to look at this. The value of the resistance here is 3 ohms, right? Good. The value of resistance here is 2 ohms. Good. The value here is 5. All right, even though we already have the diagram, but it's necessary for us to see how the arrangement can be done without then the final value here is 10. So what do? Quickly we do that. 10 ohms, right? Good. So it's time for us to start. First of all, the first one to calculate is resistance in series. Resistance in series network. So we have series is the first one to calculate. By the time we calculate the series network, we calculate the parallel network, and at the same time we add them together. So series formula is going to be RT, all right, plus is equal to R1, okay, R1 plus R2, because the two resistors are in series, R2. So what do? Quickly we substitute. When we substitute here, we have 3, we have 3, okay, plus 2. When we have 3 plus 2 is going to give us 5. So this is going to be equal to 5 ohms, all right? 5 ohms. Good. So in series we have that. So our RT in series is given as 5 ohms, right? Great. So we have solved that part. Then the second part we are going to solve is the parallel part. We can start from this point. The parallel part is another part. The second part we are going to look at, after which we combine the parallel part of the network. Parallel part. This is becoming something interesting, right? Parallel part. All right, so that's it. The parallel part is 1 all over. The formula for calculating parallel resistance is 1 over RT, right? Good. Then it's equal to 1 over R3, okay? According to the numbering, R3, yes, and then plus 1 all over R4, okay? Then after which we substitute. Very simple. We substitute. So how do we substitute? Very simple. We have all equal to 1 all over R3 is 5. We write 5. All right. Good. Then R4 is 10. We write 1 over 10. All right. 1 over 10. Good. And what do? We find the LCM. Okay, or we do cross multiplication and then get the remaining parts. But the LCM here is just 10. All right. By the time we solve this, remember we are solving for 1 all over RT. Okay. After which we are going to find only RT, the total resistance. So what do we have here? We have 10 as the LCM of 5 and the 10. So 5 divide 10, we have 2. 2 times 1 is going to be 2, right? Good. So we have another 1. 10 divide itself is 1. 10 divide itself is 1. 1 times 1 is 1. Nothing changes. And at the end we have 3 over 10. Good. We have 3 over 10. But it doesn't end there. Remember we have inverse. We have inverse here, right? Okay? We have inverse, and also we have here 3 over 10. We have 3 over 10. So it's very, very important. We need to pay attention to this now. So what do? To remove this inverse, we introduce inverse as well. Okay, we introduce inverse both sides. So this inverse is going to take care of one. We have RT automatically is RT, right, is equal to, now because of this inverse, okay, we have is going to invert this, it becomes 10 over 3. 10 over 3. Okay, it becomes 10 over 3. By the time we take care of that, look at this, it becomes 10 all over 3. Very good. And this probably will give us some decimal points, which is 3.3. We can just have 2 decimal points, 3.33 measured in ohms. But that is not the final answer. All right, that's not the final answer. Let's see what happens. Now we have found the total resistance in the parallel side, that is this side. Then we also found the total resistance in the series side, that is this side. Okay, so very, very important. What do we do now? We combine. Therefore, the total resistance for the complete network is RT. Therefore, the total resistance for the complete network is RT is equal to series connected resistors and the parallel connected total resistance. That is 5 for series, total resistance in series, plus 3.3 for total resistance in parallel, right? 3.33 for total resistance in parallel, right? So this will give us total of 8.33 ohms. 8.33 ohms. Let me get my eraser. I need to delete certain things for clarity purposes, okay? All right. So by the time we have this, now we can now we go back again and complete this. 5 plus 3.33 is going to give us 8 point, right, 3 ohms. That is the total resistance in the first figure of figure 1, so to say. So this is our answer. Very simple. Good. Okay, that is the way to do it. Don't mind the writing, don't mind the diagrams. What happens here is very simple. You are expected to calculate, okay? Calculate. That's what matters. Calculates the entire resistance in the series parallel network. And that is what we have just done now. Thank you for this moment. Remember to subscribe. Remember to share with your friends, your students, your networks. Remember to give us some thumbs up and also to hit the bell button for constant notification. Each time something like this is uploaded, you will be among the first set of individuals that will be notified. See you in my next lesson. Before I forget, drop that topic that you want me to treat next.